So we're continuing to look at three resistor circuits, and so we had a series going into a parallel, and so now let's flop it around and let's do a parallel going into a series. And so what we're going to do, we got a 3-volt battery, and let's build it this way. When we come down here with one of our 4.7, well, we put our 4.7 kilo ohm that way, and then we're going to branch it out, and we're going to put our 1.5 kilo ohm over here and our 2.2 kilo ohm over here, and we're going to call this R1, R2, R3. Now, in the previous one, I made a bubble around kind of the two outlying resistors that were in parallel. Now my bubble goes around two resistors that are in series. So now I can consider those. This is really simple. RA is just going to be R2 plus R3. So RA is going to be 1.5 kilo ohms plus 2.2 kilo ohms is going to give me 3.7 kilo ohms. And now that is going to be in parallel with a 4.7 kilo ohms. So 1 over R total is going to be 1 over 4.7 kilo ohms plus 1 over 3.7 kilo ohms. And hopefully you guys are getting better at doing this on your calculator because you guys are actually doing it rather than watching me do it. So why don't you do it first, hit pause and do it, and then come back. So I get 1 divided by 4.7 second EE3 plus 1 divided by 3.7 second EE3, and then I've got to flip that, and I get 2.07 kilo ohms. 2.07 kilo ohms is the total, and so now my total current is going to be 3 volts divided by 2.07 kilo ohms, and I'm going to get 1.45 milliamps. And once again, I'm going to start talking about R1, V1, I1, R2, V2, I2, R3, V3, I3. Well, I know my resistor values. Now, remember, in the last one, the current was what all fed into the first one. Now, if I think about it, this is a little bit different. I've got 3 volts here and I got 0 volts there. They're only going to drop if I hit a resistor. No drop, no drop, no drop, no drop. So that point is at 3 volts. No gain, no gain, no gain. That's at 0 volts. That's at 3, that's at 0. So my voltage drop across my 4.7 kilo ohm resistor is going to be 3 volts. Now that means that my current in that resistor is going to be 3 divided by 4.7 second EE3, is going to be 0.64 milliamps. And we saw that in a previous video. We came up with that exact same in a previous video. Now, if I've got 1.45 milliamps here, and I've got 0.64 milliamps here, now the current is going to split. So 1.45 milliamps is cruising in here, 0.64 goes this way, so there's got to be the current in A has got to be 1.45 milliamps minus 0.064 milliamps. My current in A has got to be it's got to be 1.45. Oh, I just did something totally wrong. I'm sorry. 1.45 milliamps minus 0.64 milliamps is going to be 0.81 milliamps. So there's got to be 0.81 milliamps going that way. So I know that now I'm safely in a series circuit. So since I'm safely in a series circuit, it's going to go 0.81 in there. So 0.81, and then that same 0.81 has got to cruise through here. It says 0.81 milliamps over here. Now I can figure out a couple of voltage drops. V equals IR. So if I've got 0.81 times, and the kilo and the milli are they're gonna cancel each other out. So I can do 0.81 times 1.5 is 1.22, and I can do 2.2 times 0.81, and I'm gonna get 1.78 or 1.78. And not surprisingly, those two, 1.22 and 1.78, are going to add up to 3 volts. And so 0.64 milliamps and 0.81 milliamps are going to add up to my total current, which is 1.45 milliamps, and then my two voltages, this should be 3 volts, this should be 0 volts. I have a voltage drop of 1.22 and a voltage drop of 1.78. I've got a larger voltage drop in the larger resistor. I've got more current going into the side that has less resistance. Everything is making sense to me. It might not be making sense to you, but it's making sense to me. We're going to come back in the next video and actually measure it out rather than jamming it into the next 60 seconds.